Today we'll solve systems of equations in 3 variables. So when solving a system, we want to be able to manipulate it in such a way that we can use back substitution. We call this row echelon form. So notice in our system, the top equation has 3 unknowns, the middle equation has 2 variables, and the bottom equation just has 1. It almost has like an upside down stair step pattern with leading coefficients of 1. Now in this class, we don't care if the leading coefficients are 1, that is not technically a row echelon form. As long as we have 1 variable, 2 variables, and then 3 variables, we are pretty good. So if we look at our first type of problem, notice it says we are going to solve the following system. And because we have 3 unknowns in the first equation, and then if we look at the middle equation, there's just y and z, and the third equation just z, we're just going to use back substitution. So y plus 3 times 2 equals 5, or y plus 6 equals 5, y equals -1. And then for equation 1, notice we have x minus 2y, 2 times -1, plus 3 times z, which is 2, equals 9. Or x plus 2 plus 6 equals 9. Or, it's an arrow. X plus 8 equals 9. Or x equals 1. And then we just write our solution as an ordered triple, 1, -1, comma 2. And that's it. So notice for order triple, we write our solution as an order triple x, y, z, or in alphabetical order. So when we start doing elimination with 3 variables, there are a couple things that we can do. We know eventually we will be doing the same situation with a matrix, but the following row operations on a system of linear equations produces an equivalent system of linear equations. I can flip the position of 2 equations if I want to. I can multiply one of the equations by a non-zero constant. Remember, if you multiply all the variables, you also have to multiply the right side. And the third thing you can do is you can add a multiple of one of those equations to another equation to replace the later of the 2 equations. Okay, that would be like our elimination process. So if we look at our system of equations that we have here, which variable jumps out at you that is easiest to manipulate or eliminate? If it were me, I would probably choose to eliminate probably z, because the coefficients for all 3 z's are fairly small. I know the common multiple of -4 and +2 is 4, so I would choose to multiply equation 2 by +2. Okay, so 6x plus 6y plus 4z equals -6. And we're just going to recopy equation 1. So 5x minus 2y minus 4z equals 3. When we add down, notice the z's cancel out. 11x plus 4y equals -3. And remember, when we add, we can replace the latter of the 2 equations. So I'm going to say this is my new equation 2 because it is the later of the 2. Now after each step, I like to recopy my system just so my thinking process is nice and structured. So we know we have the original equation 1 and original equation 3. And I'm going to put the new equation 2 in place of old equation 2. Okay, so if I got rid of z in equation 2, I also have to get rid of z in equation 3. I have to be consistent. So we know the common multiple of 4 and 3 is 12. So we'll multiply equation 1 by 3 and equation 2 by 4. Okay, so 5 times 3 is 15x. 3 times negative 2y is negative 6y. 3 times negative 4z is negative 12z. And 3 times 3 is 9. For equation 3, we know 4 times negative 2x is negative 8x. 4 times 5y is 20y. And 4 times 3z is 12z, positive. And 4 times 3 is 12. So when we add these down, we know 15 minus 8 is 7x. Negative 6 plus 20 is 14y. Z's cancel, and that's going to equal 21. And I'm going to replace the letter of my equations. This is my new equation 3. So I'm going to recopy my system from the previous step. I'm going to put old equation 2. And I'm going to put the equation, the red equation, 11x plus 4y equals negative 3. And I'm going to insert my new equation 3. So 7x plus 14y equals 21. And then we're just going to go through the same process. Would you like to eliminate x or y? In this case, it doesn't really matter. I'd probably choose y, because I know the common multiple of 4 and 14 is 28. I'm going to multiply equation 1 by negative 7. Remember, when I add down, I want to get 0. So one of the y's has to be the opposite sign. So negative 77x minus 28y equals 21. And equation 3, we will multiply by positive 2. So 14x plus 28y equals 42. Okay, 77 minus 14 is negative 63x. Y's cancel. And 21 plus 42 is 63. So here we'll get x to equal negative 1. This is my new equation 3. So when we recopy our system, notice we'll have the 5x minus 2y minus 4z equals 3. The 11x plus 4y equals negative 3. And x equals negative 1. So now that we have 3 unknowns, 2 unknowns, and 1 unknown, we can use back substitution to find our 2 remaining variables. So when we plug x equals negative 1 into equation 2, we'll have negative 11 plus 4y equals negative 3. So 4y is going to equal 8, or y is going to equal 2. And now we'll find z. So we have 5x, so 5 times negative 1 is negative 5, minus 2 times y, which is 2, negative 4, minus 4z equals 3. Negative 9 minus 4z equals 3. Okay, so when you add 9, negative 4z is going to equal 12, or z is going to equal negative 3. Final answers to write our solution as an ordered pair. So x is negative 1, y is 2, and z is negative 3. The end. Let's look at another example. So which variable appears to be the easiest to eliminate? In this case, it doesn't really matter if you do x or y, whatever your preference would be. You could get rid of z again first if you would like to, just because they're opposite signs already here and here. That means we would multiply equation 2 by 3. So 6x minus 9y minus 3z equals 15. And we're just going to recopy equation 1. Okay, so would we add down? Notice we'll have 7x minus 11y equals 22 plus 15, which is what, 37? Okay, so that's our new equation 2. Okay, so just like with these problems, I like to recopy the previous system for every step. And notice we have old equation 1 and old equation 3, and we're going to insert new equation 2. Now, if I got rid of z in equation 2, I also have to get rid of z in equation 3. So we're going to multiply the top equation by 5, because the common multiple of 3 and 5 is 15. So 5x minus 10y plus 15z equals 110. And then we're going to multiply equation 3 by positive 3, because they're already opposite signs. So 9x plus 3y minus 15z equals negative 96. Okay, so the z's cancel. 14x minus 7y equals 14. And that's our new equation 3. So I'm going to recopy my system from the previous step. So old equation 1, the equation 2 we found in the previous step, and my new equation 3. And I would probably choose to get rid of the x, because 7 and 14 is manageable. So I'm going to multiply equation 2 by negative 2 so that the x's have opposite signs. Negative 14x plus 22y equals negative 74. And recopy equation 3. X's cancel. We know 22 minus 7 is 15 equals negative 60, and we get y is equal to negative 4. That is our new equation 3. So I'm going to copy my system. And insert my new equation 3. All that's left for us to do is to do some back substitution. So we know we'll have 7x, negative 11 times negative 4 is positive 44. Seven x is going to equal negative 7, or x is equal to negative 1. And then we also need to find y. Negative 1 minus 2y. Oh, my bad. We have y is negative 4, so negative 2 times negative 4 is positive 8, plus 3z equals 22. 7 plus 3z equals 22. 3z equals 15, and z is going to equal 5. All that's left for us to do is to write our solution as an ordered pair. And we're done. I want you to take a hot minute and try this example you try. Okay, so hopefully you found the solution to be 4, 1, negative 2. Now, there is more than one correct way to work out this problem. This is just one example of a solution. So in our last type of problem, notice we have a certain brand of cavity-preventing spearmint chewing gum comes in packs of 6, 12, and 24 pieces, and they cost $2, $3, and $4 respectively. The store sold 12 packages containing a total of 162 pieces of gum and took in $35. How many packages of each type were sold? So the first thing we have to do is to determine what is our unknown. Well, we want to know how many packages of gum are sold. So that means our unknowns, we can say X, Y, and Z are the 6-pack, the 12-pack, and the 24-pack. And notice we have 6 pieces, 12 pieces, and 24 pieces, obviously. And then notice we have this total gum. So we know we can set up an equation that refers to the total gum, which is the 6x plus 12y plus 24z equals 162. We also know that the store sold a total of 12 packages, so we can say x plus y equals 12. And then the last thing we have is regarding the money. So we know that there is altogether $35, and we have 2x, 3y, and 4z. And all we have left to do now is to figure out how many of each pack that we have. So that's weird. Of our system, we have to ask ourselves which variable is easiest to eliminate. I would probably go with x. So if that were the case, I'm going to multiply equation 1 by negative 6. Negative 6x minus 6y minus 6z equals negative 72. Recopy equation 2. Add down. Notice the x's cancel. 6y plus 18z equals 90. And this is our new equation 2. So we're going to rewrite our system. And we're going to insert our new equation 2. So if we got rid of x in equation 2, we also have to get rid of x in equation 3. So we're going to multiply equation 1 by negative 2. Rewrite equation 3. Add down. X's cancel. Y plus 2z equals 11. And this is our new equation 3. So we're going to rewrite our system from the previous step. Insert new equation 3. Now, which looks easier to eliminate, y or z? I don't feel like it really matters. I'm going to eliminate y because the numbers are smaller, so we'll multiply equation 3 by negative 6. So negative 6y minus 12z equals negative 66, and recopy equation 2. Add down. 6z equals 24. So z equals 4. So that means we have 4 packs of 24. Okay, so now we're going to rewrite our system. And now we're going to use back substitution to find x and y. So we know 6y, 18 times 4, I believe, is 72, equals 90. So 6y equals 18, and we get y equals 3 packs of 12. And then we're going to find x. We know we'll have x plus y, and y is 3, plus z, which is 4, equals 12. We do get x equals 5 packs of 6. And because this is a context problem, we are just going to circle our final answers in context. Yay, practice time. The end.